Yeah, it's been, last couple of weeks with the testnet has been a little crazy. And I've kind of missed doing these updates. So now that I didn't make the testnet launch deadline I set for myself yesterday, I guess we're back to doing updates. uh, it's a very long one. I try not to look at it too much. uh, okay. I think I'll give people a few more minutes to join, but I'll go ahead and let all of you early risers in on the agenda for today. We're going to go over. We're going to sort of recap testnet 1, what happened, and what went wrong that caused us to halt. Well, that caused testnet 1 to halt. I'm going to go over the remaining issues for the audit, of which there's really only one, but it's a sizable design challenge. Going to talk a little bit about what we've learned from why testnet 1 halted and the design challenges we have to really fix that problem. And I'm going to talk about some new features that really expand the capabilities of Gravity, so much so that we're not really sure how to use them yet, or exactly how they will be used yet. I mean, we have a few downstream consumers, but there's a lot of interesting possibilities. So that's roughly going to be our agenda for this morning, and I'm going to give everybody else a minute or two to show up, and then I'm just going to dive right in. We're just the vast majority of the validator set ended up getting slashed because they weren't signing, they weren't doing the things that they needed to do to continue participating in bridge operations. And this was really the success of testnet 2, in that we moved on from the testnet 1 problem of having signers not participating and losing control of the bridge, the broken net problem, not testnet 1. Testnet 1, we slashed a bunch of people, and our goal in testnet 2 is to both retain control of the bridge and to not end up being so chaotic for the validators. With that overview sort of covered, I'm going to get into more of the technical details of why this happened. So there was a bug in the logic that handled the generation of validator sets. So ideally, you want to generate a new validator set every time the power on Cosmos, the total voting power, changes by a certain percentage. And this is a nuanced question because voting power on Cosmos, the total amount of voting power changes as more coins are issued, whatever. But the voting power on Ethereum is normalized, and this is where our problem lied. If there were few enough validators in the set, or inflation was high enough, the absolute power of the Cosmos validator set could change more than 1% every block, which would cause us to generate a new validator set to be relayed to Ethereum every block, even though no validators had entered or left the set. So, not really obviously, but by the time the powers were normalized to be sent over to Ethereum, there wasn't really a change. There was no good reason to be making these validator sets. But the chain did make them, and this sort of caused a feedback loop, namely that more validator sets were created. So when validators went to check if they had signed the sets, the request endpoint started taking a very long time to iterate through all the validator sets. So if so the program that was performing the signing with the Ethereum keys, if they were running it, then their validator would start to slow down because too much disk I/O. and they would be slashed for not signing blocks. If they weren't running it, they would be slashed for not signing validator sets. So this catch-22 drove the chain to a halt. And like I was highlighting earlier, the real victory here is that when the chain halted, the remaining validator set still had control of the bridge. And that's really the outcome you want, because the hardest part of gravity is keeping these two sides in sync. Obviously, once we fix a bug that involves generating too many validator sets and having everybody fall behind, etc., keeping the two sides of the chain in sync is a big victory, and is something that I want to highlight here, as meaning we have probably reached the point in gravity's development where we are not going to lose control of the bridge without active sabotage or exploitation, which is good, because this means we are roughly ready to progress to the next stage of our testing, which is the incentivized testnet, in which somebody will hopefully do some active sabotage and exploitation, and help find those different bugs. Now, in between this last testnet, testnet 1, and our incentivized testnet, we're going to put what I'm calling testnet 2, and I'm hoping to launch this coming Sunday. And that's going to include a lot of fixes, because while I've explained overall why testnet 1 is halted, we're not going to just fix one part of the problem, we're going to fix every element of the problem. So in addition to solving the issue where too many validator set updates were made, we're also going to add in a feature that will safely clean up validator sets behind. I should get into that in a minute, because it's actually really interesting. That will clean up validator sets so that the list never gets long enough that validators have to choose between signing things for Gravity Bridge and signing blocks. So we also need, before our incentivized testnet, to finish one last issue for our Gravity audit. First of all, I should thank Informal for doing the Gravity audit, as they've done an excellent job and highlighted a lot of issues, many of which we said to ourselves that we would do later and then forgot about, and they found all of those, which is really excellent sleuthing on their part, and gave us a lot of confidence in the quality of their review. Now, the one issue in their preliminary audit report that remains before they can come back and perform the rest of their audit is evidence-based slashing. So what I mean by evidence-based slashing is actually pretty similar to what you would see for evidence-based slashing in a traditional Cosmos chain. So I think it's called equivocation, which is where a validator signs two of the same block, and then you can present that signature and slash that validator for malicious behavior. What we're talking about is a similar check, except for the gravity segment of the bridge. So if the validator were to try and sign two of the same, for example, let's say a validator were to try and sign two different validator sets, each with a different, and the reason they would do this is because they have to submit one to the Cosmos chain to avoid being slashed, and they then are going to try and use the other with a cabal of hostile validators to take over the bridge and steal all of its funds. So slashing slashing validators for these extraneous signatures is actually interacts with the problem we were just talking about. So I was talking about there being too many validator sets to sign. Too many validator sets, and it caused the endpoints to be too slow. So we want to try and keep the state as clean as possible. At the same time, we need to carry a hash of every validator set we've ever produced forever, so that we know when somebody submits a signature and it says, hey, some validator has signed this validator set and it's hostile, it's invalid. Well, we need to go through a list of all the sets that have ever existed and say, oh yeah, this isn't a valid set, they shouldn't have signed this, and we should slash them. So this is a good problem for like a Merkle tree, or something like that. But for now, I think we're just going to separate the index, have a permanent index of validator set hashes that is ever growing, and just make sure that we never iterate over that index, except when somebody submits evidence at a rather high gas cost. It's not the most elegant solution, but it will get the feature in there sooner rather than later. Are there any questions about all of this, or the audit in general, or that sort of stuff, before I move into new features and other things that we're doing? Mm-hmm.
Cosmos or only on Cosmos, and then if you sign an invalid Ethereum transaction for the unlock, then you slash them on Cosmos.
Yeah, so that's a good question. Um, the only collateral in this system is on the Cosmos side. So this is part of our design has been to co-opt the Cosmos validator set and make their stake sort of pull double duty. Um, in addition to so in addition to being so in addition to their stake on Cosmos being at stake to run that chain on the Cosmos side chain, it is also at stake to maintain control of the Ethereum assets. And this is an important distinction and an important design constraint of Gravity, um, which is not something that was included in the design goals of the Peggy bridge. So the Peggy bridge was envisioned as a peg zone, where there were assets at stake via IBC on another zone. Gravity does not do this. The only assets at stake is the native token of the chain that is attached. Um, does that answer your question?
So you're saying essentially that there is some sort of, like in the validator set, you're mapping a Cosmos address to an Ethereum address of like a bonded validator, and then you also have functions in Cosmos where you can verify those Ethereum signatures and figure out if they were, and then slash based on that, or you have them sign something before you send over to Ethereum with their.
Both of those, actually.
Okay.
Yeah, so
Okay.
your understanding is pretty good. Um, what we have on the Cosmos side is that validators register an Ethereum key. So they send a message with their validator key, which says, "Hey, this is my Ethereum key." Um, and from then on, they are required to have an external process use that Ethereum key to sign certain things. So the chain will produce certain things that it expects to be signed. And they must submit a valid signature using that Ethereum key. The chain checks that the signature is with the key that they provided and is valid for the data that the chain has generated. Um, and then once their signatures are in, relayers can then take these signatures, assemble them into an Ethereum transaction, and submit them to the bridge, which just acts as a multi-sig for these keys. Um,
Gotcha.
Now, the slashing condition that I was just talking about, evidence-based slashing, is something going the other way. So a relayer sees a signature on Ethereum and it says, "Hey, this isn't on the Cosmos chain. This validator's trying to attack trying to perform an attack." And it takes that signature,
Mm-hmm.
brings it back over, And the Cosmos chain interprets this signature, says, hey, this is a valid signature from a validator, but it's not over anything that but it's signing something that it wasn't supposed to sign. So now it slashes it.
Gotcha. Cool.
Yeah, thank you.
Justin, is that coming in testnet 2 or the incentivized testnet?
That's going to I'm going to do my absolute best to get that in testnet 2 by this Sunday. But if not by then, it'll be in an upgrade to testnet 2. Testnet 2, I guess I should put it this way: testnet 2 will not be ending until this feature is in and tested. Because we need to finish. We need to at least reach the point where the audit can progress before we move on to an incentivized testnet.
I've got a question.
Mm-hmm.
Um, did the validators stop working because they were too overloaded for reasonable hardware, or because they were trying to run on hardware that just wasn't up to the task?
The validator stopped working because they were too overloaded for reasonable hardware. Um, the issue was this is why we're solving this issue in depth. So the problem was that when you that the program we call the orchestrator that performs the Ethereum signing actually hits this endpoint very often, and this endpoint is, hey, tell me what validator sets I haven't signed that I need to sign. And the implementation for this is not very efficient. It's essentially O of n times n, where m is the number of validators and n is the number of validator sets. So as the validator sets went up, it became punishingly harder to run, and it was hit more and more often.
All right, so running on bigger hardware was not a reasonable solution to this
No,
then.
no, no, not a reasonable
Yeah.
solution. Um, maybe if you ran in a RAM disk. In addition to all of this, we were really killing the mempool at the time because the orchestrator was using the legacy amino transaction endpoints, which do not have a very good way of telling you if your transaction was successful right off the bat. And as such, they were just sort of spamming these endpoints. So there was a bunch of IO load on the mempool, and also with this lookup, and also there's a new validator set every block. So you're iterating over tens of thousands, hundreds of thousands. It just gets worse. Um,
Right. Yeah.
and the only way to maintain equilibrium, and the chain limped on like this for quite some time, is that validators kept on dropping out of the set. So the m value in that O of m times n kept going down, and even as n continued to increase every block. So yeah, it was interesting to watch the failure mode. But definitely informative, and this is why we run these big all-up test nets, um, because this informed us that we had validator set pruning. Like when it was first merged, Jack made pruning code, and it was pretty good. The issue is that, but we thought that so yes, there was validator set pruning. It was just too aggressive. It would happen over a pretty short time window, um, just about 6 hours. And since Gravity is designed to work with any EVM chain, it's reasonable to assume that an EVM chain could halt for more than 6 hours. So what happens if you delete the last valid validator set and there's nothing to update? So like your validator set changes, like so let's say that your validator set changes completely within 6 hours while the EVM chain is halted, and you've cleaned up the old validator sets that would have allowed you to transition between the state that was on the EVM chain when it halted and the current state of the Cosmos chain. Well, now you're screwed. You've lost control of the bridge. Um, the solution to this is to keep validator sets for a long time. Um, but as we learned in this testnet, That's a contradictory problem. You can't just keep validator sets forever, which is what we were doing for on this testnet. We're just like, oh, we can't prune them that quickly. Well, it's not a big deal. There shouldn't be that many. Yeah, so there ended up being that many, of course.
Yeah, interesting.
So this is, and I think, and the reason I'm highlighting this is because I think that it's a great example of why we need test nets like this. Because we had a problem that we understood, we implemented a solution that we understood, and the test net told us that our solution was not good enough. Um, there's no like protocol flaw or design flaw or anything with that other than, hey, in practicality, this solution doesn't work. And that's what test nets are good at telling you.
So I have just an additional question, which is, how do you make sure that the bridge never has too much money in it, such that it would actually make sense for these validators to just collude and steal the money instead of being honest, right? Is there some sort of like collateralization ratio, or is that on the end user to ensure that they're not pegging money into a bridge that is more profitable for these validators to steal from than to operate?
Yeah. So this is another. Once again, this is an excellent question, and it is part of the reason that we decided to name this project Gravity rather than Peggy, because Peggy was the originally envisioned Cosmos to Ethereum bridge from the Cosmos white paper, and it included solutions to these sorts of problems. Gravity is a bridge for the hub, and right now our consideration is that Gravity is going to run on the Cosmos hub. It's a multi-billion-dollar blockchain, and we can deal with this as the amount of locked assets even comes close to that value. And choosing to rely on the existing stake of the Cosmos chain and not get into collateralization, over collateralization, extra collateralization, really simplifies the bridge design. And this was the choice we made, and it restrains us to operating on larger chains with more collateral. But we don't see that as an enormous problem with IBC. And right now it's worth the design trade-off. Maybe once IBC continues to mature and things like staking derivatives and cross-chain staking derivatives and stuff like that really become very standard foundational parts of the Cosmos ecosystem, we can consider solving these problems. But it's also sort of chicken and chicken. It's also sort of a chicken and egg problem. We want to get Ethereum support to the Cosmos ecosystem as quickly as possible to help it grow, to have the resources and the interest in solving those problems in the first place.
Gotcha. Thank you for that answer. That makes a lot of sense. Yeah, I mean,
Cool. So I guess I'm going to move on to our next schedule, to the next item I have on my agenda, um, which is to talk a little bit about the arbitrary logic feature that we have added to Gravity. So this is one of the most requested features. Um, is that obviously Ethereum is a full programming environment, not just a token holding environment, and depositing and withdrawing ERC20s is great, but is rather small scope compared to the entirety of Ethereum. And that is what arbitrary logic is designed to address. Essentially, how it works is that a module on the Cosmos side can tell the Gravity Bridge, hey, I want to make this contract call on Ethereum. I want to fund it with the following tokens. Um, and then the Gravity Bridge module will handle getting that message signed and that code executed on Ethereum. It will also return it will also return the returned value in an event from Ethereum. Um, And there are a lot of good contributors who helped design this. My co-founder of my co-founder of Althea, no, co-founder of Althea, my co-founder of Althea, Jahan. Sorry, I just had my coffee. Um, and I think it was Albert at Injective that suggested that we include the return code, which is really smart. Um, and Yeah, and then Sommelier, of course, who was the main driver for this feature and their entire team. Um, but the cool thing about arbitrary logic, although right now it's only exposed to other Cosmos modules, I would like to expose it to all users, so that anyone on a Cosmos chain using Gravity uh, can can say, hey, I am on Cosmos. I have all these tokens that I've bridged over, and I would like to run this contract call on Ethereum. Why don't you handle it for me? Um, and so that is something that Gravity Bridge will support. And I think that's really cool. It has a lot of possibilities. It also opens up the possibility of using the Gravity Bridge as a generic Ethereum oracle, although it will be rather expensive since you get return data into the Cosmos chain from whatever your call is. You could write a contract that dumps Ethereum state, does nothing but returns a bunch of state. Then you just run that call, and you bring the state back into Gravity. While this is not the most efficient oracle ever, it does allow chains already running Gravity to do a lot of things that would otherwise not be possible. If you really need something specific, and and you need to do it a lot, you would probably want to try and extend Gravity to add this feature specifically. But this gives chains the flexibility uh, to try to try anything that's interesting, and more importantly, the speed to interact with new DeFi contracts and new paradigms um, as they come into existence, instead of on the timeline of how quickly you can deploy something new to the hub or deploy something new to a running chain. Um,
So,
yeah.
what are the other applications other than like Oracle? Um, so this is only for going from Cosmos to Ethereum, not from Ethereum to Cosmos. Like,
No, this also goes from Ethereum to Cosmos. So that was actually something we finished just a few weeks ago. Gravity V2, we called it. And you can take Cosmos-based assets and issue them on Ethereum. How that works is that somebody comes along and they call an endpoint on the Ethereum contract, which deploys an ERC20 token uh, to represent the Cosmos asset. If it was deployed with the correct parameters, the Cosmos chain will accept this new representation. And anytime somebody tries to bridge Atom, for example, over to Ethereum, they will give you some of this new ERC20 token instead. And that token is now the Atom representation on Ethereum.
gotcha. So what I'm talking about specifically is like, is this extensible enough or like open enough when you're going from Ethereum to Cosmos such that you could peg in any asset type by specifying the call data and the contract to call?
Uh, you can peg in any ERC20 asset. Um, right now, the issue, and we're probably going to try and add NFTs once there's an NFT story over on Cosmos, just because nothing to there's no uh, there's no standard
Is
module
Elliot
for it to link an
asking?
NFT.
Yeah, because is Elliot asking about NFTs? Is that what you're asking about?
I'm really just asking because you guys are saying like essentially you have like this really open and flexible thing where you can execute any arbitrary logic. And so my mind
Yeah.
essentially just goes to like other types of tokens that you could theoretically,
Yeah, I would
yeah.
say that the weakness in the way arbitrary logic is implemented right now is that it is funded with ERC20s. So what happens is that when you have an arbitrary logic call, you're saying, call this contract with these arguments and send it these ERC20s before you do so. And that's obviously the gas for this is being taken care of by the relayer, and they're being compensated in ERC20s. And the contract that you're calling could have a non-ERC20 token in it and do something with it, but the arbitrary logic itself will not fund those, and the bridge itself will not be able to interact with these non-ERC20 tokens. Now, the way I see solving this problem in the long term is what I call a headless gravity contract, and that is a contract that, for example, locks up ERC20s and can send ERC20s and do arbitrary logic calls. Sorry, not ERC20s, non-ERC20s. So a headless gravity contract would be another contract that can interact with, let's say the NFT standard. And what it does is that it's headless. So it looks at the main gravity contract for its validator set and what signatures it will accept. But it holds and accepts and manipulates NFTs. And that is a solution that we can use long term. It is a little inconvenient in that you'll have several different addresses that you'll have to figure out where to deposit the address. But it will allow the bridge to be extended for arbitrary token standards without us having to know what they are right now, without having to put in a contract upgrade proxy, which is a whole rabbit hole of its own.
Okay, so one last question from my side. So with arbitrary logic going from Cosmos to Ethereum, how do you prevent someone from just saying, give me all the tokens in the bridge, like just calling an ERC20 and just doing a transfer from the Gravity contract to their address?
Yeah, so this was a big design goal that Jahan did a lot of research on. And what we do actually is that we use, I think it's call. I'm not the biggest Solidity expert myself. But what happens is that the arbitrary logic function call itself includes an amount of funding. And on the Cosmos chain, you validate the amount of funding. So you say like, oh, hey, somebody wants to make an arbitrary logic call. They say they want to fund it with 50 DAI. Do they have 50 DAI? Yes. Okay, then that's great. I'm going to put this in the store for all the validators to sign and then relayers to relay. And when it reaches the Ethereum contract, the tokens, the DAI is sent to the contract, and then the contract is called as part of one operation. So the contract that is called with this arbitrary set of arguments, arbitrary contract, it has its own. It has just been funded by the arbitrary logic call, but it can't spend more than the funds that it was sent. So let's say I have the Gravity bridge contract, which has all the funds, and then I have Foo contract, which is going to do whatever. When I do an arbitrary logic call, the Gravity contract sends 50 DAI to Foo contract, which will then spend it on its operation. But Foo contract cannot spend more than the DAI we have just sent it, unless it already had it, at which point it got it from somewhere else other than the Gravity bridge that we don't care about.
Will also be published when the audit is all wrapped up and all the evidence handling stuff is all finished. Then we'll of course publish the formal audit.
This is already documented. If you go to Cosmos Gravity Bridge, it's either specs or docs. Then there's an arbitrary logic MD file, and it outlines how exactly this all works. I'm going to be expanding. So as we lead up to finishing the audit, expanding documentation is a continued priority, and I'm going to be trying to add a new documentation document a couple of times a week for the next month or so, until that's a very complete outline of what's going on. But arbitrary logic is already there, so you should be able to go and look over the design and how it works.
Cool.
Cool. Well, I think unless there are any other questions about anything at all, I'm happy to talk about all things gravity.
Let's tell them where they can find out more information and how to stay like in touch. I'm going to put a Discord link in the chat for any of y'all that aren't in our Discord. We have an announcements channel, which is a good place to stay in touch with what's going on. We also, of course, post on Twitter.
Yeah. So the Discord Gravity Bridge channel on the Althea Discord, the Althea Validators channel on the Althea Discord. We have updates in our announcements group, among other things, and there's also the Gravity Bridge channel on the Cosmos Discord, which we try and update with all of our major announcements as well. Although we don't create quite as much noise there as we do on our own Discord, and we try and keep the signal to noise ratio pretty high and focus on stuff like we're starting a testnet, we're doing a stand-up, sort of larger things. So if you want to keep up with the day-to-day of Gravity Bridge, you should be in the Althea Discord. But if you're in the Cosmos Discord, you're getting all the information that is really important, and you won't miss anything big.
All right. Thanks to everyone for being here, and thanks Justin and all the great folks that are working on Gravity. Until next time.
I'd like to, and I'd especially like to thank all of the participants in our Althea Gravity testnets who have been invaluable at helping us really sort things out and make fast progress and really follow the Althea philosophy of getting feedback from reality.
Thanks, Justin. You're doing great. Appreciate all your hard work.
Thank you. Well, cool.
Have a great day. Thank you.
Have a great day, everybody.
Bye.